Hello everyone, my name is Mario Tiozzo and I'm the Data Analysis and Visualization Librarian here at UNB Libraries. Today we're going to take a look at how to analyze the data in this spreadsheet to calculate confidence intervals for a sample mean. Once again, we will be using a modified version of the PISA 2022 data for Hong Kong. For the purposes of this video, we will just use the reading score data in column O. Let's copy and paste this in another sheet to focus on this data series. So we go to the top of the data series here, click on the first data point, Control-Shift down to get the entire data series, Control-C to copy, click on another tab, Control-V to paste. So first things first, what is the confidence interval of a sample mean? It's essentially the spread around the sample mean where you would expect a population mean to fall within a certain confidence level. So if your confidence level is 95%, for example, and your population mean is X, you would expect X to fall within the confidence interval of a similarly constructed sample 19 out of 20 times, or 95% of the time. Now that we know what a confidence interval is, how do we calculate it? So in order to calculate it, we will need to find the sample mean, which should be easy. We've done this several times. The critical t value, along with alpha, and a standard error. So let's get to it. Let's ease into this by calculating the sample mean. This is simply the mean of the sample, so we can use the average formula to do this. We do this by going to an empty cell, pressing the equal sign, typing in the name of the formula, in this case average, opening the parenthesis, going to the first data point in our data series, Control-Shift down to get the entire data series, and close the parenthesis, press enter. So the average is 503.675 points. So let's tag it, sample mean. Great. Next, let's calculate alpha, which we are told here is 1 minus the confidence level. Let's set our confidence level at 95% for now. This is a pretty standard measure. So let's put in confidence level. Let's set it at 95%. So if our confidence level is 95%, what's our alpha? Well, if it's 1 minus the confidence level equals 1 minus the confidence level, it should be 5% alpha. But we're not looking for alpha here. We're looking for alpha divided by 2. So let's divide this value, our alpha value, by 2. So let's call this alpha divided by 2. Next, let's calculate our critical value. The critical t value comes from the student t distribution and helps us make inferences on the population data using sample data. Before we calculate the critical t value, let's calculate the number of observations. Trust me, we're going to need it in a few instances to complete our calculations. We remember that we can do this by using the count formula. So let's go to an empty cell. Let's click this one. We press the equal sign, the name of the formula, in this case count, open the parenthesis, go to the top of the data series, click on the first data point, Control-Shift down to get the entire data series, close the parenthesis, press enter, and there's our number of observations. Number of observations. Great. So we have 5,907 observations in this data set. Okay, now that we know the number of observations, let's get back to the critical t value. To help us calculate it, Excel has a formula to do this, T.INV. We do this by going to an empty cell, pressing the equal sign, the name of the formula, T.INV, opening the parenthesis. Notice that this formula requires two arguments, the probability, in this case our alpha, and the degrees of freedom. So let's click on our alpha, and let's remember that we use the divided by 2 for the probability requirement. Press on a comma to tell Excel that we are moving to the next argument. And now degrees of freedom. The degrees of freedom is equal to the number of observations minus 1. So the number of observations is here and minus 1. Close the parenthesis. Press enter. Notice that this number is negative. This is because we are doing a one-tailed test. There's a formula for a two-tailed test if we wanted to use it. And since we're using a one-tailed test, this is for the left tail, so it's negative. We can get the right-hand tail to make it positive, but in order to do that, we need to do 1 minus alpha divided by 2 in our formula. So let's go back in here, and instead of putting alpha divided by 2, let's put 1 minus alpha divided by 2. We get the exact same number, except now it's positive, because now we're in the right-hand tail. So we get 1.96037 for our critical t value. Let's tag that. Critical t value. Okay, we just need the final component, the standard error. That's simply the sample standard deviation divided by the square root of the number of observations. We already have the count, so let's calculate the sample standard deviation. We do this by going to an empty cell, pressing the equal button, the name of the formula, STDEV.S, .S and not .P. .P is for population, and we have a sample, so we'll want to use .S in this case. Open the parenthesis. Click on the first data point in our data series. Control-Shift down to get the entire data series. Close a parenthesis. Press Enter. Okay, this is our sample standard deviation, and it's 98.25737 points. Now all we have to do to get the standard error is to take our standard deviation and divide that by the square root of the number of observations. Again, we go to an empty cell, press the equal sign, click on a standard deviation in E7, divide that by the square root of the number of observations. There's a formula for the square root, SQRT. Open the parenthesis and click on number of observations to get the square root of that. Close a parenthesis, press Enter. So our standard error is 1.27844. Let's tag it, sample standard error. Great. Okay, we now have all the components to calculate the confidence interval. We need to take the sample mean and add it to the product of the critical t-score and a sample error. Note that it's a plus minus, so we need to do the same thing again, but this time subtract the product of the critical t-score and a standard error from the sample mean. So let's do that. Let's take our sample mean and add it to the product of our critical t value and the sample standard error. Press Enter. Let's call this upper limit. Let's calculate the lower limit now, which is the same thing, except now we take the sample mean and we minus out the product of the critical t value and the standard error. So what does this mean? With a 95% confidence level, we would expect the population mean of the reading score in Hong Kong to fall somewhere between 501.168 points and 506.181 points. Another perhaps simpler way of calculating the confidence interval of a sample is to use the Confidence.T formula, which calculates the margin of error. The margin of error is the product of the critical t value and the standard error. Put in margin error here. Let's press the equal sign, the name of the formula, in this case Confidence.T, open the parenthesis. Notice that this formula requires 3 arguments: alpha, standard deviation, and the size. So let's click on alpha for the first requirement. In this case, we want the regular alpha. Press the comma to tell Excel that we are moving to the next argument. Let's click on the sample standard deviation for the standard deviation requirement. Again, we press the comma to tell Excel that we are moving to the next requirement. And finally, let's click on the number of observations for the size requirement. Close a parenthesis, press Enter. This gives us a margin of error of 2.506217. From there, we can simply add and subtract this from our sample mean to get our upper and lower limits respectively. So let's do that here. Double check that it's the same number. We take our sample mean, we add the margin of error, press Enter. Yep, it's the same number. Let's do it again, except this time we take our sample mean and minus out the margin of error. Press Enter, same numbers. Terrific. Okay, that should do it for now. We've learned different ways to calculate confidence intervals for a sample mean. I hope that this was helpful. Thanks for watching, and I'll see you in the next video. Bye for now.